Bum, bum, bum. All right, and we're back. So we left off talking about cloud, and now we're going to resume talking about cloud. So a few notes from the early days, right, back around 2010 or so. You guys can't see this, but you can see this. This one is from 2010, late 2010, so, almost 10 years ago. Basically, what are the problems? Well, data growth is the big IT challenge. Data growth is the biggest data center hardware infrastructure challenge for large enterprises, blah, blah, blah. 47% of the respondents conducted over the summer ranked data growth in their top 3 challenges. 62% said they plan to expand hardware capacity. 30% plan to build entirely new data centers. So this was a big problem, right? Most of these organizations, they did not really want to be in the data management game at that scale. If they could have found somebody to provide a service and handle all of that data for them, they would be very happy to pay them for the privilege, right? Analogous, all these manufacturers, they don't want to be in the electricity game, right? They don't have their own generators supplying electricity to all their factories, right? What they really want is to be able to plug everything into a wall and have electricity come to them, and they'll pay the utilities prices for that. Same kind of thing. All right. So that's the state of where it was. And a little article from The Economist as well. So cloud was a big thing. Let's see how that goes. Data everywhere, right? So again, what was this from? Damn it, too many. I don't want to, again, early 2010, so same time frame. Information has gone from scarce to super abundant, brings new benefits, but also big headaches, right? Basically, organizations are having trouble managing and retrieving all of this data. So it was a big thing like 10 years ago. Okay. So let's talk about utilization some more. So let's say your organization has a major one-day promotion, right? Like say you run a Super Bowl ad and you saying, here's our product, come to our website to learn more. And because it's a Super Bowl and because like 100 million people worldwide watch it, you get a lot of traffic to your website. So you have to be prepared for that. You have to be prepared for basically, let's say, 100 times normal traffic. So there's 2 options, right? Assuming you want to actually deal with that traffic, the 2 options are this. Number 1, you maintain your current system. Well, if you maintain your current system, it's probably not going to be able to deal with 100 times the usual traffic. If it did, you would have a whole lot more servers than you ever actually need on a typical basis. So what will happen is your site will crash due to heavy traffic, right? So many people will come to your site, the servers won't be able to keep up with delivering the pages, and you're going to lose some sales. All those people that wanted to check it out, they're going to go to your site, it's not going to be there and functional, and they're going to think, well, this business doesn't know what they're doing. They can't manage the traffic, and they don't come back. Other possibility is you expand the system. So you set up extra hardware in advance of running this ad, verify that it works correctly at, large scale. But afterward, after the ads run and you have that short-term traffic surge, then you have a lot of mostly unnecessary capacity, right? You're basically having 100 times more servers on hand than you actually need. And neither of those options is very good, right? That's not what you want. What you want is to be able to, for just that one day or two, have very high capacity, but not actually pay the hardware costs of setting all that up. So capacity sharing is where this comes in, right? So in a sense, that's what the cloud operation is doing. They have a lot of extra capacity and they're leasing it out to various clients. So suppose one organization has a lot of excess system capacity, right? It could be idle servers, a lot of extra data transmission capacity, right? So all the cabling in their system is not terribly busy. They could run applications for other organizations, could handle their website traffic, could store their data, right? So in all those different dimensions, some other organization has excess capacity and they can lease it out to new clients. Now, 3 different ways this can happen. Number 1, time. So time sharing is the oldest of all these, and it's roughly as old as computers. So the very first computers, right, they pretty quickly figured out that whatever they wanted to do with it wasn't going to require the entire capacity of the computer, right? They would design it to solve one problem. Once they had solved that problem, they could use it for other problems. But eventually, and they'd have to recode it, and that was kind of a hassle. But what started happening at various research facilities is that the computer would run one application for one slice of time. For example, it would work on one complicated math problem, take like half an hour to do that, and then somebody else would come along and want to do a different kind of math problem, and they would run that through the computers and take a while to do that. And there would be this kind of time splicing involved where sequentially the computers would do different things. Hardware, right? Once you go from having having one computer, one big monolithic machine that can essentially run one application at a time, to a group of interrelated pieces of hardware like a server tier, then you can start leasing out particular servers, right? So if a cloud organization has 1,000 servers or 10,000 servers, it can lease part of them at different intervals, right? So on one particular day, your organization needs a lot of capacity, you rent out 100 servers from this cloud. Other days, if you don't need so much, maybe you're only renting out 5 or 10. The final stage that really made cloud work, though, so this is all right? This is better than having to keep it all under your own roof. But the real benefits, big benefits, happen here with virtualization, where essentially you create the equivalent of servers, but those applications and the data storage spread over many different machines. So you're leasing the same amount of capacity, basically 100 server equivalents, but you're not necessarily renting out 100 specific machines. You're renting out all the stuff that 100 different machines would do, but you might have a tiny slice of stuff going on 10,000 different machines. Right? So the difference is, fundamentally, if you're renting a particular server, right? Let's say you're running Microsoft Office, and you got PowerPoint, or that's not PowerPoint, let's say that's Access, and you got PowerPoint, and you got Excel, and you got Word, and you have one machine that does that. Let's recolor that. Okay? And you want to run that on a bunch of different machines, yeah, you can do that. But what tends to work better, what's a more efficient grouping of things, is if you have a little slice of 4 different servers, and on each of them, you run that one application. Okay, and this allows, just like with server tiers where you can scale them separately, this allows the possibility that maybe you have a lot of need for Excel, right? Maybe at some point you need like 400 copies of Excel up and active, but only 100 of Microsoft Word, and maybe only 25 of PowerPoint, and maybe 50 of Access. You can scale those separately. Yes? Those are specific machines. The black boxes are servers, right? So one option is this, renting specific hardware, and you put all your apps on that specific machine, right? You could do that. The other option, virtualization, the cloud assigns apps and data to potentially different machines. And the nice thing about that, they can be scaled separately. So again, if you're renting out so many virtual machines, right, you basically want to say, oh, we want to treat everybody like they have a desktop in the cloud. Everybody can do all those things all at the same time. But if you've identified, hey, we don't actually need, maybe we need 400 copies of Excel because everybody's using that, but maybe we don't need anything like 400 copies of Access or PowerPoint or Word. We don't need to pay for 400 server equivalents, right? So this one, I'm just going to say 400 copies of Excel requires 400 servers, right? Whereas over here, maybe 400 copies of Excel and let's say 100 each of Access, PowerPoint, and Word equals 700 divided by 4 equals 175 server equivalents. Okay, that's the idea. In this kind of virtualization, you can really have a fine-grained thing of only renting out exactly what you need. If you're renting out specific machines, yeah, you got to rent out specific, specific machines, and it's going to cost you more. Okay. So, cloud computing started to catch on around 2010. And you might fairly ask, well, why not sooner? Because remember, number one, various resource sharing models, they've been around for decades. Resource sharing, especially time sharing, was literally 50, 60 years old by then. Storage wasn't a problem, right? Anybody can, set up a rack of hard drives and have that. So storage is never the problem. And server clusters were available. Servers weren't new, right? Basically, all these businesses, they had all this same hardware under their own roof. There was no real reason why one big umbrella organization couldn't provide that as needed to individual businesses. Well, the real critical factor was fast connection speed. So let me give an example. This is a real problem. So up until about 2010, one of the big things that was a problem. Let's suppose your organization has 100 gigabytes of data, okay? And let's also suppose you have a 1 megabit connection, right? We call it a T1 line, which was pretty good for around 2000, right? The year 2000, if you had a T1 line, that was pretty good. That was a pretty high data rate, okay? All right. So how long would it take to transfer your data over that connection? Well, let's do some math. Okay. How many bits are in 100 gigabytes? How many bits are in a byte? 8, correct. So therefore, 800, right? We'll say 100 gigabytes equals 800 gigabits. Okay, lowercase b for bits. Now, if I can send 1 megabit per second, right? That's what a 1 megabit connection means. It requires 800 gig divided by 1 meg seconds to transfer, right? To transfer the data equals 800,000 seconds. How long is 800,000 seconds? How many seconds in a day? You don't know. You should know that. How many seconds in an hour? Close. Close. It's 86,400. 86,000. I'm not going to ask you that on an exam. Okay? Anyway, yes, so 3,600 seconds per hour times 24 equals 86,400 seconds in a day. So roughly 10 days to transfer the data, assuming nothing goes wrong. And this is a big problem, right? 100 gigs of data in the year 2000. Yeah, a big business is easily going to have that, right? I mean, I had my little desktop at home that came with a 6 gig hard drive. A business that actually is doing real information, they're going to have probably more data than that, right? More data than 100. I'm just saying the data transfer problem is big. Keeping up with new data as it happens is a problem. Until you get these super fast connection speeds, right, it becomes a real thing. Now, there are offline data transfer services. Like Amazon has a thing called Snowball. Snowball is basically you put a hard drive in a suitcase, or maybe a solid state drive these days. Put that in a suitcase and it carries a petabyte of data. They have another one called Snowmobile where they drive like a trailer truck full of these Snowball suitcases up to your organization. You can load like 100 petabytes of data onto that. They even have an exabyte version of Snowmobile where basically they hook 10 of those trailers together that can each hold 100 petabytes, exabyte of data. So Amazon has these online data transfer services, and typically, if you do something like that, it'll get processed in a few days, right? It still takes a little while with that volume of data to get processed, but direct machine-to-machine cabling can go a lot faster than, secure transfer over the internet, because things have to be chopped up in different ways and wait for other traffic and be secure and all that. Anyway, but those also take time. Anyway, the point is this. If a business realizes at some point they want to extract their data from the cloud, right? They've got their foot stuck in it, but they can't get their foot back out because it takes them literally 10 days to get all their data, right? Or they have to call them up and do some kind of online, offline data transfer, which wasn't as highly synchronized back then as it was now. Businesses, they thought, well, we just want to have all of our data under our roof. We want to be able to check this stuff. So the real thing, the real last limiting factor was fast connection speed. So in many cases, it was feasible to process organizational data locally. For example, if you wanted to transfer your data from one machine to another, you could do that under your own roof. But if you wanted to do something like pull all your data back from the cloud to put copies of it on different machines, that was going to be a huge headache. It just wasn't going to happen. All right, so if you're interested, like from 2011, a little article about cloud bottleneck issues talks about how data transfer is one of the big things. Okay. Now, cloud is way more than just machine replication. So machine replication means you're creating a copy of your existing system up in the cloud somewhere, right? That's what machine replication is. Whatever your system is, how all your computers are, and how they're connected together, machine replication is trying as far as possible to replicate that exactly in the cloud. Now, if you do that, yes, you can get economies of scale because you're not paying for all the hardware all the time. You're only paying for, the changes you need when you need them. So it still solves that problem, right? Our Super Bowl ad problem like this, where you have 100 times normal traffic. So one day, boom, you can have your same kind of system up in the cloud, but just running on 100 servers. And a few days later, you shrink back to your usual 5 or 10. Okay, you can still do that. You can still get some savings there. And the cloud provider will have less control, right? It won't be able to put all of the applications and all the data where it's most accessible. So all that stuff we talked about with caching, like with Oracle's times 10 system, cloud systems can do things like that too. If there's data that you really want to have be accessible, the cloud will realize that and it can make it more accessible. On the other hand, data that isn't, quite so often looked at, that one too, you can put that where it's not cached. But if you're telling the cloud, yeah, I want to set up this system exactly in this way, the cloud doesn't have quite as much latitude to arrange that data. So because of that, because you're renting out specific machines under machine replication, basically you're going to pay more. So whether those machines are used a lot or whether they're used a little, they're essentially exclusively yours and you have to pay for it. Okay. So cloud generally, sorry, it's a little hot in here. I see the ball. Yeah, it's just unpleasant. I don't know. I think what happens is they only change the temperature in these buildings twice a year. And so if you have, unexpectedly warm weather in October, it gets like this. Anyway, with more flexibility, right? Cloud can break up applications and components deployed across servers, right? This is exactly this here, right? They can say, oh, I see, this is what you need. I can break up these applications, put them on different machines. You don't have to rent out 400 specific machines, each running a full suite of Microsoft Office. We can just give you the application copies you need when you need them. Okay. And again, generally, things that are used a lot, the cloud is going to try to make them most accessible because it's good for the cloud and it makes the customers happy, right? Because, for example, if you have one item in your cloud that's always being called for, lots of people are accessing that data, the cloud wants to store that in RAM so it minimizes the burden on the rest of the system, right? Otherwise, the cloud has to replicate that data to a bunch of hard drives, and if it's still really popular, that's all those hard drives are going to be able to do. Cloud doesn't want to do that. Cloud's going to say, oh, this thing is super popular. We have a bank of RAM for caching. We're going to keep that there for you. Okay. Now, cloud attributes. So, of course, the first thing a cloud needs, you need some excess capacity, right? So if you're an organization like Amazon, you got your own stuff to do. The cloud, right, is basically stuff you're renting. That's excess capacity that you can rent out to other people. So you do need to have that. Otherwise, you won't be able to fulfill your own obligations. But what else is needed for a viable cloud service? Well, two key things. Flexible contracts, right? The ability, you don't want to try to lock people into 6-year contracts at the same volume of servers because that would defeat the point, right? If you required people to sign on for like a multi-year contract at a specific volume of usage, the organization is going to say, well, we might as well buy all those servers ourselves if you're making us effectively buy them over, their useful life. The other thing, easy, fast, reliable communication, right? So all those factors, has to be secure, has to be fast, so that any data updates that happen in the organization can be immediately reflected in the cloud, and anything that happens in the cloud can be immediately grabbed back by the organization. So the volume of data transfers has to be really high for this to happen successfully. Now, cloud services have 5 essential attributes. Some of these we'll talk about in a little more detail. So shared resources, right? The cloud owns a bunch of different servers. It rents out some of them to different clients. Elastic leasing, that means you can quickly change the terms of the contract. So again, rent 100 servers one day, scale it up to 10,000 servers the next day, bring it back down to 100 servers the day after that. Metered, you have to have some way of measuring what people are using, right? So if you're doing just renting specific machines, then you pay them by day per machine. But if you're looking at, a breakdown of something like this, you can charge them for the amount of storage they're using. You can charge them for the amount of data traffic they're generating within the network. You can charge them by the number of CPU cycles they're using in your system. So if you're doing some big data number crunching problem, that could be a lot of CPU cycles. Otherwise, if you're doing something like MS Word, maybe not so much. Okay, all those different metrics, whatever usage of the cloud system you're using, they have to be able to track that. Service-based. We'll talk about that. We should get to that today. And then over the internet. Cloud services, strictly speaking, don't have to happen over the internet. But if you're going to make a cloud service and sell it to the broader world, people are going to want to come over the internet to get it, right? You're not going to use some kind of proprietary networking technology. Not going to reinvent the wheel that way. Okay. So, main benefit of using the cloud is that operating costs are much, much lower, right? Short version, you only pay for the capacity you need. So, for example, right, you wouldn't have to have 100 servers under your roof and have them be mostly idle most of the time. And the cloud provider brings economies of scale to bring down costs for all users. So one of the things you'll see, let's see if I can find it here. So they have these things called server farms, right? And here's the, this is a good one. So you see this building here? It looks like a big warehouse. Trust me, there's a bunch of servers in there because it's a server farm. That's what it is. But how many vehicles do you see? What kind of parking lot is there? Not much, right? Not much. There's maybe like 10, 20 people, some security guys, some network administrator types, maybe a few, repair guys, whatever. You don't need that many people to run this kind of server farm, right? Whereas if you're a business and you got 10 servers under your roof, yeah, you still need a maintenance guy, probably. You still need a network administrator, right? So you have like a couple people for 10 servers versus, so like a 1-to-5 ratio versus a couple dozen people for 10,000 servers, like around 500 to 1,000 servers per person. You can save a lot of money on that, right? There's other economies of scale too, but personnel is a big one. What? Different one. This one? This is Google, I believe. Yeah, but anyway, that could be what it looks like inside. Google's super secretive about its data centers, but I do have some articles that, yeah, I think this is an image from a Google article. Yep. I mean, you could spend $1 billion on one. You could spend more than $1 billion. I mean, but like rough numbers, all right, you want numbers. It depends on how many servers are in there, for starters. How much does a server cost? And there's all kinds of different models out there, right? It's like asking how much does a smartphone cost? You can buy a cheap one for like $100. You can buy a cutting edge 5G one for like $1,500. There's a lot of leeway in there, right? But some of these, this one is $95,000. This one is $1,300. So, different machines with different capabilities. But say if you have like 10,000 of these $1,000 ones, that's 100 million. Okay, 10,000, no, that's 10 million. If you have 100 of these $100,000 ones, that's $1 million. So if you have 100 times 1,000, that's a lot. I'm just saying that's a lot of money. Okay. 10,000 times 10,000 times 10,000 is a billion, I think. No, shit, 1,000 times 1,000 times 1,000 is a billion. All right, my point is you can spend a lot of money on these things, right? That's really the takeaway here. So let's say $1 billion, 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. And let's say you have 10,000 servers, then 100,000 for each one. So yeah, if you have 10,000 of these, which I'm sure are pretty awesome servers, 10,000 of those would be $1 billion. If you have 10,000 of these cheapy ones, it'd be substantially cheaper. All right, but mostly the big players like Amazon and Google, they don't have really the cutting edge machines. They have, fairly ordinary midline hardware that tends to be cheap. It's that right balance between functionality and not breaking down and not costing too much, but they have a lot of it, all working in parallel. Okay. Anyway, so the point is, the user gets a benefit because they only have to pay for the capacity they need. And the cloud, because it's so big, it gets that kind of economies of scale. It can provide the service cheaper than the organization could do by itself. Other benefits, very low risk of traffic overload. I mean, once in a while, yeah, it can happen, like Amazon Prime Day, but cloud systems almost never get overloaded. Like, when was the last time you went to Facebook and couldn't get in because it was too busy, right? Basically doesn't happen. There's a thing, do you guys watch that Social Network movie? Yeah, there's a little scene early on, I forget, where he's like talking to Justin Timberlake or his own people, whatever, and Zuckerberg's kind of having a meltdown because, Facebook got overloaded and shut down, as I recall. He's like, this should never happen. People are going to go somewhere else. Yeah, it basically doesn't happen. Automated backup and recovery, that's very nice. You don't have to worry about that. You don't have to specifically delegate that as a task. The cloud is going to build that into its cost structure. Hardware and software upgrades, right? Again, this is something the business doesn't have to worry about. Just like you plug your devices into the wall, you don't have to make sure the utility for electricity is using up-to-date, equipment, whatever it may be. Same thing for the cloud. You just don't have to worry about it. It's great. And last, probably better security, right? It's not an absolute certainty that's better security. And yeah, clouds have had their own security problems over the years. But yeah, in general, cloud security at this point, after 10 years in the business, tends to be better than the security of ordinary non-cloud businesses. Okay. Shared resources. So, to achieve economies of scale, cloud providers are typically very, very large. So they have a lot of clients, and those clients tend to have different usage profiles. So that tends to smooth demand. So, simple case. Okay, so here's over the course of the day. Whoop. And we're going to make this problem as simple as we can. So we're going to divide the world into two halves. We're going to have Western Hemisphere, and we're going to have Eastern Hemisphere. Okay? And let's say the Western Hemisphere is like 70% of our business, which is probably roughly true for Amazon, and the Eastern Hemisphere is 30%. Okay, they're over in Europe and Asia, but, they're still, most of their stuff's happening in the U.S. Okay? Now, here we'll put in some times. So here's 12:01 a.m., and here's noon, and here's 11:59 p.m. Okay? Now, let's say the U.S. one is busy, like from noon to 8, right? So it has a usage profile something like this, okay? Likewise, Eastern Hemisphere has a usage profile that's, 12 hours opposite. So it's going to look something like, as it's going up, it's going to look, but it's not as big. So it's going to look something more like that, which means, right, the overall sum of these two is going to be something like this, meaning it's relatively flat over the course of the day, right? I mean, I'm kind of overstating it there. It's maybe more like, is it going up, going down? Okay, maybe it's more like that, but the point is, it's relatively smooth. If you're one individual business, your usage profile is probably going to look more like this, right? Dead until the morning, spikes up, maybe flat, maybe a big spike right at the end, and then dead for the rest of the day. So your utilization, basically all you're getting out of this part, this is the part of the day where your organization is busy, right? The rest of the time, your machine's kind of sitting idle. Okay, with Amazon, because their system has a lot of diverse clients and their needs aren't, highly correlated, you get a fairly smooth amount of data traffic, network usage, system usage, whatever. And they can plan for that much better than a simple business can. Simple business can't really do much about the fact that, its business is going to be busy when it is. With Amazon, has a lot of different clients, tends to have fairly flat usage of the system, which means they can plan a lot better. They don't really have those spikes in peak demand like a single organization would. Okay, so this is another example of scale advantages. So competitors, if they're smaller, they don't get that advantage of smoothing demand, right? They have essentially a smaller sample size, fewer clients. They're not going to get that kind of balance in most cases, so they can't smooth demand as well. Their overhead costs are going to be bigger. And last, because Amazon is able to provide this cloud service at a lower cost, that can use that to attract new customers, right? If Amazon already has such scale advantages that it can charge, 20% less than the next biggest cloud organization, that itself becomes a selling point. Okay, so this is the thing. When I teach 520, I teach half of that course, the network infrastructure part. And I always have a question that about half of the class misses. I say, how does Amazon, provide, what is the one key thing that lets Amazon's web services provide higher utilization and thus lower cost than an individual organization or smaller cloud services? And a lot of the students will say stuff like, well, because they serve a lot of clients or because they have advanced hardware. Well, advanced hardware is absolutely not true. That's not what it is at all. If you say that Amazon serves a lot of clients, well, yeah, but the point is, if all those clients had the same usage profile, if they were all like that one business that, is busy, is dead half the day and has like a single spike at the same time, Amazon wouldn't get any of these demand smoothing benefits. They'd still have to allow capacity for peak demand and be idle the rest of the time. The important thing, they have a lot of different clients with different usage profiles, okay? And that lets demand be smooth. And that means Amazon, their peak to average ratio is a lot less than for a single organization. Okay. So, a few more things. Basic cloud models. So, there's 3: public cloud, private cloud, and hybrid cloud. So, in a public cloud, the service is open to any customers. Basically, you can sign up, get an account, go ahead, start using it. In a public cloud, though, data is not guaranteed to be isolated from other users, right? You might have some of your data on the same machines as some other people. So again, think about it in terms of Facebook. Facebook doesn't maintain a dedicated server for you, right? It mixes data together from a bunch of different users for different people. Like, so even though I've uploaded a fair number of photos to Facebook over the year, I can't imagine I've uploaded even 1,000. 1,000 photos at like a meg each is 1 gigabyte of data. That's not even going to come close to filling up a hard drive, right? So Facebook is not storing all my stuff on one machine. Wouldn't be cost effective. However, public cloud can offer premium options for isolation and selecting a particular location as well. So you might say, well, public cloud, but instead of having my data mixed up with other people's, I'm going to rent out specific machines. That's an option you can have, but you're going to pay extra for it. Private cloud simply means one customer has exclusive use of the cloud service. Now, typically, right, it means the organization owns the cloud, but it could be outsourced, right? It could be that you pay somebody else to just manage your stuff, right? But most of the time when people talk about true private cloud, they mean that it's internal to the organization. In general, this sort of system is going to be more secure, and it might be necessary for legislative compliance. There are certain industry sectors like finance where businesses have to keep their own data, but it's also going to be more expensive than public cloud. You're not going to, if you're managing the cloud yourself, you're not really going to get that much in the way of savings in terms of scale. Other option, hybrid cloud. Hybrid cloud's various combinations of the above. You also have something called a community cloud. Community cloud is basically a small-scale cloud for a group of related users. For example, you have 2 or 3 or 4 businesses all working together jointly on some project. You might set up, a standalone cloud system so that they can all use that together. Community clouds aren't quite as big. There was a window like 10, 15 years ago where people thought, hey, maybe these are going to be a big thing. They haven't gotten quite so big because a lot of the times public cloud is secure enough that you don't really need a separate cloud. Anyway, okay, elastic leasing. Like I said, elastic leasing just means you can change resource allocation at very short notice. And if the cloud service is big, that kind of change is not going to be very disruptive to the service provider, right? So you have a lot of different clients with weekly correlated requirements. That means if one guy is asking for a lot more system usage, that means probably somebody else is asking for less, and it's about going to be a wash most of the time. The other thing is, even if there's a surge in traffic, right, like at Amazon, they're so big that if some guy comes along and says, hey, we want to, use 1,000 server equivalents for a day, that's not going to be that big of a thing for Amazon. Amazon's system is so big, they'll be like, yeah, okay, we can do that, right? Other cloud services might be smaller. They might say, ooh, 1,000, yeah, that's going to be hard. How about 150, right? But for Amazon, they're big enough, they can do things like that. And it doesn't happen that often. It doesn't happen that often where a business needs to jump from like 50 servers to 1,000. And if it does happen, it doesn't need to happen for very long. Anyway, how is this similar to and different from electrical utilities? Well, in principle, anybody can plug into the wall, right, and get whatever electricity they need. But what's this? Sometimes surges happen, right? It's very hard for the electrical companies to deal with a sudden long-term surge in usage, right? So with cloud, the organizations are already big. It's fairly easy as these things go to integrate more servers to add more capacity that way. They can manage it. For electrical utilities, basically they have to build new generators, right, and put them in some place and connect them to the power grid. It is not a trivial thing. It's going to take a lot longer to add that chunk of capacity to an electrical utility than it will to a cloud. But, they can both suffer from surges, right? Like towards the end of summer, it gets real hot. A lot of people use air conditioning. Yeah, the electrical utilities, they might just start to have a little trouble keeping up. Occasional brownouts, blackouts, whatever. All right. So, metered, there's not much to say. Elastic leasing, if you're going to have that, if you're going to allow people variable usage contracts, you need to have some method for tracking what resources are used, right? So, and these can be on different dimensions. For example, if 2 users have different storage requirements, they're going to get charged differently. If 2 people are using a different number of CPU cycles, more computations, they're going to get charged differently. So, there's all sorts of different charging rates. We'll look at cloud contracts, payment options at the end. You can charge per server if you want to reserve a specific number of machines and have them be exclusively yours. You can pay for that. You can pay for per unit of storage, right, like hard drive space. You can pay per unit of virtual RAM. You can pay for per unit of data traffic over the network. There's all sorts of different models for who gets charged for what. All right. So this is a good break point, I think. We'll come back on Friday. We'll talk about services and service-oriented architecture and all that stuff. Any questions before we go? Yes. Monday, what's that? Yeah, Jeopardy will be in class, yes. Yes. Okay. Yep. There you go.